Can humans ever leave the Milky Way galaxy? Have you ever looked up at the night sky and wondered about the vastness of our universe? We live on a small planet, orbiting an average star, nestled within the sprawling arms of the Milky Way galaxy. But what if I told you that one day, humanity might just leave our galactic home behind? It sounds like science fiction, right? Well, today, we're diving into the mind-boggling possibilities and incredible challenges of galactic exodus. First, let's grasp the sheer scale of what we're talking about. The Milky Way is a barred spiral galaxy, an immense collection of stars, gas, dust, and dark matter. It's estimated to be about 100,000 light-years in diameter. That means light, traveling at an astonishing 299,792,458 meters per second, takes 100,000 years to cross it. Our solar system is located in the Orion Arm, about 27,000 light-years from the galactic center. So, if we wanted to leave, where would we go? Our closest galactic neighbor is the Andromeda galaxy, another spiral galaxy even larger than the Milky Way, located approximately 2.5 million light-years away. It's currently on a collision course with our galaxy, but don't panic, that's not expected for another 4.5 billion years. Beyond Andromeda, the universe is filled with billions of other galaxies, each a distant island of stars. The distances are truly mind-boggling, far beyond anything we ever travel. Traveling within our own solar system is already a monumental task. A trip to Mars, for instance, takes about 7 months with current technology. To reach the nearest star, Proxima Centauri, which is only 4.24 light-years away, would take tens of thousands of years with our fastest spacecraft. Now imagine multiplying that by millions to reach another galaxy. We're talking about journeys that would span hundreds of thousands, if not millions, of years, far exceeding any human lifespan. Our fastest spacecraft, like the Parker Solar Probe, reaches speeds of around 690,000 kilometers per hour for 130,000 miles per hour relative to the Sun. While incredibly fast by earthly standards, this is a mere crawl in cosmic terms. It's less than 0.064% the speed of light. To leave the Milky Way within any reasonable time frame, we'd need to achieve speeds incredibly close to the speed of light itself. This is where the laws of physics start to pose significant challenges. According to Einstein's theory of special relativity, as an object with mass approaches the speed of light, its mass increases infinitely, and it would require infinite energy to accelerate it further. This essentially means traveling at the speed of light is impossible for anything with mass. However, reaching speeds very close to the speed of light, say 99% or even 99.9999% the speed of light, might be theoretically possible with revolutionary propulsion systems. So, what kind of propulsion would we need? Forget rockets as we know them. We'd be looking at concepts like fusion rockets, which could offer significantly higher exhaust velocities, and chemical rockets, even more speculative var antimatter rockets, which would achieve the highest possible energy conversion efficiency, potentially getting us to a substantial fraction of the speed of light. Beyond conventional physics, we enter the realm of more speculative concepts like wormholes and warp drives. Wormholes are hypothetical tunnels through spacetime that could theoretically connect to distant points, drastically shortening travel times. Warp drives, as popularized in Star Trek, would manipulate spacetime itself to effectively compress the space in front of a spacecraft and expand the space behind it, allowing for faster-than-light travel without violating local speed limits. Both, however, remain firmly in the realm of theoretical physics, with no current evidence of their existence or feasibility. Even if we could conceive of such propulsion, the energy requirements would be staggering. Accelerating a spacecraft, even a small one, to near light speeds would require an amount of energy equivalent to the total energy output of many suns over extended periods. Harnessing and storing such immense quantities of energy is a technological hurdle beyond our current comprehension. We'd need entirely new ways of generating and utilizing power on an unprecedented scale. Here's another fascinating twist: time dilation. According to special relativity, as you approach the speed of light, time slows down for you relative to a stationary observer. So, while a journey to Andromeda might take millions of years for those left behind on Earth, for the astronauts on board a near-light-speed vessel, only a few decades or even years might pass. This means the travelers could potentially survive the journey, but they'd return to a vastly different future, potentially one where humanity on Earth has evolved or even ceased to exist. Given the immense timescales, any genuine attempt to leave the Milky Way might require either intergenerational starships, massive vessels designed to sustain multiple generations of humans over millennia, or be undertaken by highly advanced, self-replicating AI probes. These probes could carry the genetic material or knowledge of humanity, colonizing new galaxies on our behalf. Beyond the how, there's the why. Why would humanity want to leave our home galaxy? Perhaps it's for survival, if the Milky Way faced an existential threat like a supermassive black hole eruption or a runaway star. Or perhaps it's simply the innate human drive for exploration, to push the boundaries of what's possible and discover what lies beyond. The desire to know, to see, to expand our horizons is deeply ingrained in our nature. So, can humans ever leave the Milky Way galaxy? The answer is a resounding maybe. It's not a question of simply building a bigger rocket. It's a question of completely rewriting our understanding of physics, engineering, and perhaps even what it means to be human. The challenges are immense, bordering on the insurmountable with current knowledge, but history has shown us that humanity's ingenuity knows no bounds. While a galactic exodus remains firmly in the realm of science fiction for now, the very act of contemplating it pushes the boundaries of our imagination and inspires us to reach for the stars. Thanks for watching, and remember to keep looking up.